Hello, my name is Oscar Gregoire, and today I'm going to be teaching the Unit 9, Lesson 1, which is on imaginary numbers. Okay, so let's start off with reading what is written down. So the imaginary unit I is the number whose square is -1. I2 equals -1. So, an imaginary number is any number that contains the imaginary unit I. It takes the form of a plus bi, where a and b are real numbers, but b is not equal to 0. So, some examples are 3i, -5i, pi I, 6 plus 3i, -2 minus 4i, -1 plus the square root of 3i, 6 plus I, square root 7, -1 plus square root 3i, 6 plus I, square root 7. So when a equals 0, the number may be referred to as purely imaginary, such as 3i, -5i, etc. So for exercise 1, it's pretty simple, self-explanatory. You're just graphing, but here's the kick. So the two axes, they're different. The one that's going vertical is the imaginary axis, okay? And then this is the real numbers axis, which is going horizontal. So the imaginary number obviously goes on the imaginary axis since it has the I. So 4i will be going there. And then the real numbers will be going on the horizontal axis, which is the real numbers axis. So -3i is 1, 2, 3, and then it goes up 4, so 1, 2, 3, 4. So that's your point. You've graphed it. It's pretty simple now. So the next one's pretty easy. It's just -1, 5i, so -1, and then 1, 2, 3, 4, 5. Boop. Pretty easy. And same thing here, just instead we're going this way, they're going to the right instead of left. So 1, 2, 3, 4, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 1, 2, 3, 4. My bad, excuse me for that. Next, so now that we know how to graph and label each of on the complex plane, we're going to simplify some of the problems using higher numbers of I. So you may not know how to do this immediately, but I'm going to teach you really quick. So number 1 is I to the power raised to the power of 99. So the way you would solve this is, so for solving higher powers of I, dividing the original exponent, which is 99, by 4 can help us solve the problem, since I to the power of 4 is equal to 1. So all we have to do is we have to divide 99 by I, so 99 by 4, so 99 divided by 4 equals 24.75. That doesn't go to a whole number, so what we're going to have to do is multiply 4 times 24. So we get 96. So that is close, so what we're going to have to do is I to the power of 99 equals I 4 times 24 plus I 3. So what that does for us is it tells us that this is equal to that. We need to simplify it down. So I becomes to the 4th, take away that 24, plus I to the 3 gives us, now we have, since I to the 4 equals 1, we're just going to put 1 in there, so 24 plus I to the 3, and now we can take away the 24, so we have 1 plus I to the 3, which equals -I. Well, I to the 3 equals -I, so it's 1 plus -I. So that equals, boop, -I. So it's pretty simple. I'm going to leave the other two for you guys to solve. All you have to do is just divide the original exponent by 4, and then if it doesn't come out to a whole number, multiply the whole number in the front without the decimal by 4, and you will get like 96 when we got that. And then whatever that number is subtracted by the original number equals, that's going to be I over here plus I3. So now we're going to go over to solving some, we're going to perform some operations using I. So let's come up here. So, oops, sorry about that. So we have, for the first one, it is an addition. It's very simple. These equations, you're just adding, subtracting. It's very simple math. So I plus 6I, you don't really have to do much. You just have to add them together, and you get 7I. And then for 2, again, super simple. You're just subtracting. But, yeah, so it's negative 8I minus 7I, and you get negative 15I. And then for the last one I'm going to do with you guys is 6I plus negative 4I plus 8, and you get 32. So yeah, it's pretty simple and pretty self-explanatory, and that's imaginary numbers. So I challenge you guys to do the problems that we didn't do, and have a good day.